everyone. Can you hear me? Okay. Well, so thanks for inviting me. Thanks, Gary, for giving me the opportunity to speak. So my name's Rachel Loehman. I'm a research landscape ecologist and fire ecologist. I work here in the Southwest and then also in Alaska. Thank you. And a lot of my work is on fire effects, on modeling climate change, fire interactions, effects on forest resilience and vegetation. But beginning about a year ago, I started coordinating a large USGS initiative to link fire models and look at sort of next generation best fire models coupled with debris flow and hydrologic models to better understand the effects of uncharacteristic wildfire activity, and then the literal downstream impacts on watersheds. And so we're engaged in that work now, and so I'm going to talk a little bit about that. And then Jeannie, my colleague at the New Mexico Water Science Center, is going to talk about the efforts of that science center to better understand post-fire impacts and where we can move forward. So just to set the stage for us for New Mexico's wildfire year in 2022, which really set the stage for the whole country in terms of unprecedented, biggest, earliest, most difficult to control. We had what the New York Times called this perfect recipe for extreme wildfire, a record-breaking year here in New Mexico. It doesn't come as a surprise to any of you all. Jumping ahead to the punchline, we burned over 900,000 acres in 2022, much of that in two wildfires with some extra wildfires added in. Fire behavior was extremely difficult to control. Fire spread was extremely rapid, and the causes of this wildfire activity are what you see up here on this slide. So the driest or the near driest April on record, depending on which part of the state you're in, above average springtime temperatures, sustained high winds, weeks and weeks on end of red flag days, which are high fire danger days, all happening in the context of a long-term extreme drought, a mega drought here in the Southwest, and all happening in the context of 100 or more years of fuels accumulation that includes the effects of fire exclusion and the effects of tree mortality because of drought and because of insect activity. So again, for us, a record-breaking and an eye-opening year in terms of fire activity and fire impacts. So to give sort of an update on the status of the science of our understanding of the impacts of these uncharacteristic wildfires on flooding and on debris flows, so floods and mud. Again, we're most concerned about wildfires of uncharacteristic severity. So here in the Southwest, we have wildfire regimes that are typically high frequency, low severity. But when we change those wildfire regimes, when we change the intensity of wildfires, the amount of area that burns in high severity because of changing climate and because of this fuels accumulation issue, we get fires that burn differently than the landscape and the vegetation than our soils are adapted to. And so that's where we get this uncharacteristic behavior. We can have uncharacteristic seasonality, so fires that burn earlier in the year, which changes the response of plants, changes the ability of plants to come back to respond after fire. Fires of high intensity cause soil hydrophobicity, so that's basically water repellency in the upper soil layers that mean that water that then falls, precipitation, rainfall, that falls on those soils doesn't soak in. It becomes surface flow, and surface flow causes erosion. We also have the effect of tree mortality, so areas where large areas, as you can see in the photo on the top, where all trees have died because of fire. So when trees die, their roots shrink, they fall over, you remove important terrain anchors for stabilizing soil. The burning of surface vegetation, the litter, the fuels on the surface, and the organic matter in soils all also contribute to destabilization of soils. And so it means that you have a bunch of loose top layers of soil combined with this reduced ability of water to penetrate into the soils. And so it's sort of the perfect recipe for erosion and changes in watersheds. On top of that, you can add rainfall patterns that might be of large intensity, so really heavy rains like we get in the monsoons, and potentially long duration rains. And again, that facilitates the surface flow of water and erosion. And then you get things like you see on the bottom photo, which is an image from Valles Caldera after the 2011 Las Conchas fire. So an area where you have big changes in watersheds, big changes in surface hydrology, big changes in drainage patterns, large mass wasting events. And those things can lead to delayed forest recovery, but our forests are also delayed in recovering after fire anyway because they're recovering in the context of these high-intensity wildfires that are trying to come back during this mega drought. So all this paints a challenging picture for our ecosystems in recovering after fire, for our watersheds, in maintaining integrity after fire, and it creates a lot of challenges for us in terms of how we monitor, we model, we predict, we think about these post-wildfire hazards. And so that leads to the trends, at least the trends in science and management and application for thinking about how we respond to all the things I just described. And so in USGS, we are launching or have launched an interdisciplinary applied wildfire hazards program that links our wildfire science with our science focused on these post-fire debris flows and changes in hydrology that I described. And the methods that we are using are a combination of models and monitoring. So linking the best possible fire models driven by or fed by three-dimensional fuels, which is the photo on the top there, which can be mapped with aerial LiDAR or terrestrial LiDAR, methods that basically paint a three-dimensional particle level of the fuel structure on the ground. These drive complex three-dimensional fire behavior models that help us predict where and when fire intensity might be of the type that would lead to changes in the post-fire environment that are then related to the post-fire hazards. We link those with hydrologic and debris flow models. We can predict where in time and space after a wildfire we might have the highest risk or the highest vulnerability of watershed, the highest risk of changes in hydrologic dynamics and landslides and debris flows. But a part of this has to be what's really happening on the ground during wildfires. And so one of the things that we're doing is looking at real-time fire observation from satellites, so things like hotspot analysis, hotspot assessment, to see where in real time during wildfires we're getting the type of fire behavior that causes these the potential for hazards. And then we're coupling that with monitoring to make sure that we're getting it right. We model these hazards for years, not just months after wildfires. So the recovery of vegetation after a wildfire can take a long time. We think about vegetation as a terrain anchor, root masses that help stabilize soil. We might want to think about years or even decades after wildfire to recover our watersheds. We account for changing climate and that ongoing vegetation recovery I talked about. And then an important piece is to build capacity in groups that are underserved in terms of kind of inherent local abilities to monitor and predict post-fire hazards. And that here in New Mexico principally includes tribal entities. And then we think about the consequences of changes in hydrology and debris flows for human communities, for cultural resources, for ecosystems, and for species. And so we're doing this work right now in California and Washington. Next year we'll start in on New Mexico and hopefully expand this program outward. And now I'm going to turn you all over to Jeannie, who's with us virtually, to talk a little bit about what the Water Science Center has done this past year and will do for fire monitoring.
Jeannie, can you hear us? Can you speak?
Can you hear me now?
Yes.
Okay.
Phew.
Good. Okay, thank you, Rachel. I'll go ahead and transition if the sound's coming through good and we're good to go.
Yeah. And Jeannie, when you're ready for me to switch the slide, just holler out.
Will do. Thank you. So, Rachel's talked a lot about modeling really to understand the dynamics of fires, and we'll transition some to talking about how we can use some of the modeling output to identify locations for early response gauges, which the New Mexico Water Science Center, part of the USGS, has been involved in this past fire season because of these unprecedented fires. Next slide, Rachel. So the New Mexico Water Science Center has been working with FEMA through FEMA mission assignments and also our local communities here. So on this slide, you can see the Nogales-McBride fire area near Rio Doso. And what we're looking at here are the gauges that we installed as part of our FEMA mission assignments. And so for the Nogales-McBride, we installed 7 new precipitation gauges and also added an additional precipitation gauge to an existing stage discharge gauge. This data, and all the data I'll show from here on, it reports directly to the National Weather Service and really helps to fill in radar gaps and just provide more eyes on the ground so that they can get those early warnings out to the communities as quickly as possible. Next slide, Rachel. Here we're going to look at Hermits Peak Cap Canyon. This was a much more complex deployment effort because of the larger size, the terrain, how remote it was, and also the cell coverage. Very little cell coverage once you get past Las Vegas, and all of this made it more complicated. Here we installed 4 precipitation gauges shown by the white diamonds, 3 precipitation stage gauges shown by the kind of dark gray diamonds. Also, precipitation stage turbidity gauges shown in green there, and then 1 precipitation stage discharge gauge shown in yellow right near Story Lake. And we also have a couple of webcams out, one that is real time near the diversion before you get to Story Lake. This is all just to help our emergency responders, also to help with the drinking water issue at Story Lake in the city of Las Vegas. And that's also why we added the turbidity sondes to some of these gauges as well. And all of this data is available on our USGS National Water Dashboard, and again gets transmitted directly to the National Weather Service. Next slide, Rachel. Okay, but within Hermits Peak Cap Canyon, we had a little issue where we had a pretty big data gap there for that rather large area. And because this was an area where we did not have a lot of people living there, we used a different approach to get Gages Mission assigned here. And if you'll transition to the next slide, Rachel, we'll kind of zoom into that circled area. So here we actually work directly with the National Weather Service and FEMA. The National Weather Service helped us to identify the gauges that you see here. And these were all needed to help fill in the Weather Service's radar gaps, and just again to provide more eyes on the ground to get that data to them as quickly as possible so they could get those early warning alerts out as quickly as possible. And next slide, Rachel. We've also been working with Sandoval County regarding Cerro Pelado. You probably know this county was declared a little bit later on in August, and we're currently working with the Coach de Pueblo on about 5 different proposed gauges that we're waiting to get mission assigned. And then those will also become a part of this early warning network. One thing I'll say before I move on is that we're working with FEMA to get all the gauges shown here, plus the ones that we're working on with the COCHD, into a 24-month long-term agreement so that these gauges in the early warning network will be active for the next 24 months. Next slide. I just want to touch on that we also, in addition to helping, provide that data to the National Weather Service, we've also been working with the city of Las Vegas on the drinking water issue, and the USGS has been part of a federal task force to help address the drinking water issue. Our role has been primarily centered around water quality, and we'll go to the last slide, Rachel, just to show some of the water quality that we've been looking at. given the drinking water issue here. So looking at more than just debris flow, but also trying to help the city understand how the quality of the Guyanas has changed due to the wildfires and what impacts that might have on the drinking water supply. And here I'm just showing some of the different parameters that we're looking at and some links to the data. You can go online and find all of this real time. And with that's the end of my slides, and would be happy to take any questions. And thank you, Rachel, for advancing the slides.